In classical economics, to fully understand individual labor supply, we need to take a step back and think about a microeconomics topic of indifference curve. In classical economics, economists assume that a rational labor can only engage in two things, given that they have a choice. So let's say that if you were a laborer who was unemployed, what would you do? You could spend your entire day, playing and having fun and enjoying, or having leisure. And if you do that, let's take this point over here. Let's say that it's point A, and you could do that for 24 hours, since one day only has 24 hours. So you can spend the entire day having fun, having leisure, and whatever you like to do. Or alternatively, you can, let's say, take an employment, and let's say that in this situation, that would give you an income of $100. Let's say that this is $100, and if you were to work all day, you might achieve $100 of your work. In classical economics, you can either you can have fun all day, 24 hours a day, or you can work all day and make some income, or maybe you can have some combinations in between. Now let's take a step back and look at a macroeconomics topic of indifference curve. Since this is not an indifference curve class, I won't be going into a lot of details, but I just want you to understand a few basics, because it is the indifference curve which will help us understand the individual labor supply in the labor market in classical economics. Indifference curve generally is a U-shaped curve, or a semi U, you can call it. And any point on the curve, so all points on the curve, any point on the curve will provide me equal utility or equal happiness. So if I consume at any point on the curve, I will be equally happy. So let's say that in this situation, let's say that this corresponds to, let's say, 7 hours, and no, not 7 hours. Let's say this corresponds to, let's say, $100, and let's say this corresponds to 3 hours. Okay, 3 hours. So if I were to achieve $70 a day as my wage, and also get 3 hours of my time to enjoy, I would be equally happy as if I were to achieve 7 hours of happiness. And let's say this represented, I don't know, $40. So even if it's point C or if it's point D, they both provide me with equal happiness. I'm happy with both situations. Or I might achieve any point over here, let's call this point E, and I would be equally happy. All of this is represented by indifference curve. Again, we make an assumption that utility or happiness is something that can be measured, and we can visualize it on a graph, because in reality doing that is not so easy. But for the sake of argument, we do assume that it is possible. I mean, you can look more into indifference curve, which I'll make a video soon if you really want to understand what indifference curve is all about. But for simplicity, just understand any point on the indifference curve provide equal happiness when consumed, or equal utility when consumed. Any point on the right, so any point over here, this entire area would represent more utility. So if I were to have an indifference curve, let's say something like this, let's call this IC2. All of the points on IC2 will provide me more satisfaction than IC1, and any point below, any point over here, would provide me less utility, would provide me less happiness. Also, if I have any let me see if I can do that. If I have any indifference curve over here, that would, all the points on the curve, provide me proportionally less happiness than IC1. I'll be making a video on indifference curve soon, which will give you more details on how indifference curve works. But I hope that at this stage you do have a very basic macroeconomic understanding of how the indifference curves work. But for the sake of this topic, I won't be going into a lot of details of indifference curve, because this is not completely related to the topic. Now let's think about labor market. Now what does the labor market represent? So if I can quickly sketch it. We know that the labor demand curves look something like this, which we deduced from our previous video. So MRP, marginal revenue product, is equal to marginal productivity of labor, which is equal to demand for labor. When I say equal to marginal productivity of labor, just keep in mind, not in monetary terms, but in terms of the graph. The MRP graph and the MNP graph have the same shape. In some textbook they use MRP to represent the labor demand. In some books they use MNP, marginal revenue product, to represent labor demand. But they both have the same shape, so don't get confused if you're studying from a different book. Okay. A labor supply curve looks something like this. So how do we understand this labor supply curve? As the wages are increasing, our quantity of labor in the economy is also increasing. However, beyond a certain point, the curve will go and turn backward, and this is called as the backward bending. And for this reason, this is called a backward bending labor supply curve. So how do we understand that? With the two concepts we have already discussed. So let's say that for some reason now this labor, let's call this labor Joe. For some reason Joe is being offered more money. So what would the line look like? What would the budget line look like? Maybe it might look something like this. Let's say that he's also then offered another job with a much higher pay. Since we only have 24 hours in the day, that 24-hour or the x-axis will remain completely constant. We can't have more than 24 hours in the day. However, you can have proportionally higher wages. Let's say that this point represents $200. Let's say this point represents $400. You can get proportionally higher wages. So if we combine our indifference curve with the budget line, what do we get? So if I can properly sketch it, let's say this is our first indifference curve, and we know from our basic macroeconomics where the point where the indifference curve intersects with the budget line, right, budget line over here, budget line, the point where the indifference curve intersects with the budget line, it is at that point it is a rational consumer would most likely consume. And let's say that this point represents something like this. So what's going to happen if our wages increase? So we will have a different indifference curve. So let's say this is our second indifference curve. Let's call this IC2. Let's call this point IC1. And if you're offered a higher wage, that will look something like this. As you will notice, as you are being offered higher wages, so this point is over here, so this point is over here. As we are being offered higher wages, we would let go of our leisure time and we would want to work more. But this is only possible until a certain point. Over here I have a much clearer representation of what the trade-off looks like. As you can see from the graph, which I've already explained over here, as our wages increase, so as our income is offered, as the labor is offered more money, he is willing to let go of some of the leisure time to work. But what is the pattern? The pattern is initially he is able to let go a lot of time. Initially he is able to let go, let's say in this situation, 2 hours. But then if for any proportional increase in wage, he is only willing to let go of 1 hour. And this is because if you think about it mathematically, without going into a lot of details, the budget line is becoming more and more inelastic. It's becoming more and more vertical. Since the line is becoming vertical, the gradient of the line dy by dx is also going to increase. It's also going to increase. The gradient of the line is going to increase. Since the gradient of the line is going to increase, mathematically speaking, for any proportional change in income, we would be willing to let go of less. You can explain this trend either using maths, which I'm doing, or you can even explain it using indifference curve, using the substitution effect and using the income effect, and you can use that to analyze the shape of the curve also. And if it corresponds that if we correspond those points over here in this graph B, let's call this graph A, graph B, you will notice as our wages are increasing, the amount of work that we are willing to work for is going to increase, but it's going to increase at a decreasing rate. This is because, as I've already mentioned, as the amount of as the wages are increasing, our curve is becoming inelastic. So any proportional change in real income is going to have a very small effect on the amount of time that we are willing to let go for that work. And you can even think about it, intuitively. You can think about it using common sense. If I am a labor, any labor, and let's say that I sleep for 8 hours, so we can remove that 8 hours. So let's say I sleep for 8 hours on average, and let's say that I spend 8 hours having fun, and let's say that I spend 8 hours working, and this amount of work, let's say for the sake of argument, gives me a salary of $100. Now if I have been provided more income, so let's say that for some reason my employer is willing to give me $200, but in return he's asking me to work more hours. Maybe I can, instead of working 8 hours, maybe I can work somewhere around, let's say, 14 hours, and I can maybe have a little bit less fun, and let's say I can only have fun for, let's say, 2 hours. So that would make sense. So let's say the employer is willing to provide you with even more income. So initially we had a 2x increase. We're increasing our income by two times, and for that 2x increase I was willing to give 2 hours more. Let's say the employer again tries to increase my wage, and let's say this time he tries to increase my wage by 3x. Even though I might be getting 3 times the amount of money that I was previously receiving, how much time would I be willing to let go of for that, $600? Maybe only, since I only have 2 hours of leisure, maybe I might only be willing to add, half an hour. So only be willing to add half an hour, because I only have 2 hours for fun, 2 hours for leisure. For any increase in amount of salary, I won't be willing to let go of my leisure time, since my leisure time is already very less. And this is how a classical economist also think. They assume that a rational labor needs to make a trade-off between leisure, between leisure and between work. Let's say right over here, wages, between wages. And the idea is that as the amount of wages are increased in the economy, the individual is less willing to let go of leisure time, because they only have 24 hours, and if they spend the entire time working, they would not want to do that, because they would want to have some time for leisure. This is an assumption that classical economics makes. This is an assumption that classical economists make. You can understand this idea using common sense, or you can even understand the idea using maths, which I tried to do. And we can also understand the idea by analyzing indifference curve, by analyzing substitution effect, and by analyzing income effect. And I won't be going into details into all three of them, but I hope that by this level you do have a basic understanding of how the individual labor supply curve is reduced. So what's going to happen to the market if I combine all my individual labor supply? So let's say that this is my market. You have labor supply, we have wages, no problem. So let's say this is the individual labor supply of a given labor. Let's call this labor A. This is the individual labor supply of, let's say, this is very weird. Okay, let's say this is the labor supply of another labor. Let's say this is the labor supply curve of another labor. So when we combine all these curves, we will get a straight line. This is not a clear representation, but I hope you guys get the point. When we combine many individual labor supply, we get our market supply for labor. This is why in many textbooks you will notice that the labor supply curve for the market is a straight line, whereas the labor supply for individual is not a straight line. This is because in the market we are trying to combine all the individual labor supply.